Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Academy YouTuber. Bermula percuma, selamanya percuma. How are you today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our sessions by reciting a prayer according to your own religions. Let me introduce myself. I'm Teacher Tan from College Matrikulasi Selangor, the moderator for today. We at Pusat Academy YouTuber will provide you with free online classes. Let's take this opportunity to do revision. So are you ready? Let me introduce our teacher for today's lesson. We have Teacher Kong from College Matrikulasi Perak. We are live on Teacher Kong's channel today. Please support her channel by clicking subscribe now. The topic of today's lesson is hybridizations. And together with us, we also have Teacher Vivi Lau from Pusat Tingkatan 6 SMK Tinggi Kelang, who is the control host in charge to ensure the smoothness of our lesson on technical support. And also Cikgu Mawar from KPM as the observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat sessions wisely. Second, regarding certificate link, the link will be given at the end of our sessions. Please use your e-didak account when you fill in your particulars, and make sure to listen to the passcode given by me throughout the lesson, and fill in the form within the time limit, which is 30 minutes. Before starting the class, so I don't have the passcode yet, so I will give you later on. Okay, so without further ado, let's welcome Teacher Kong to start the class. Teacher Kong?
Yes, thank you, Teacher Tang. Okay. Hi, everyone. How are you today? Okay, before we start, right, I would like to introduce my pre-U chemistry team. So this is 5 of us is from pre-U chemistry team. We lead by Cikgu Shannon. Okay, Cikgu Shannon. Today he's not here, so today is 4 of us. Okay, 4 of us: Teacher Vivi Lau, Teacher Tang, Cikgu Mawar, and myself. Okay, next I would like to introduce pre-U mathematics team from Teacher Im. Okay, she is the leader. And next is biology. Okay, pre-U biology team who lead by Madam Faiza. And this is physics team who lead by Madam Rosmaya. And this one is account and economy team who lead by Madam Fizi. So let's, okay, please remember every Sunday, right, 3:30 until 4:30 p.m. Please stay tuned with us. We are going to deliver a free lesson for all of you. Okay, and then I am Teacher Kong from Perak Matriculation, have about 10 years experience in teaching chemistry. Okay, so all of you, right, please to remember, subscribe, like, and share my channel. Thank you very much. Okay, so without further ado, right, let's start our today lesson about overlapping and hybridization. Okay. Actually, right, this one is under chemical bonding. There are 5 subtopics. Part 1, okay, if you still remember, right, okay, I have taught you all, not only me, Teacher Vivila and me already guide you all how to draw the Lewis structure. And then Teacher Tang guide you all how to explain the molecular shape based on VSEPR theory. And then this one last week, okay, Cikgu Shannon, okay, guide you all about polarity. So this week, right, I will continue about orbital overlap and hybridization. So first, what is overlapping? Okay, and what is hybridization? First of all, okay, suppose, right, you should know hybrid, what is hybrid? Okay, if you learn about biology, right, hybrid between two species, for example, hybrid between lion and tiger, and then form what is the species about? Okay, we're not sure, right? If you Google and search, right, what is tiger and lion, and then they will make a like tiger lion mixed together, they will form a new species. What is the name? So go and check. Today, our topic, right, is the hybrid between orbital in terms of chemistry. Okay, so let's check. Okay, there are two types of overlapping. The first one is end-to-end overlap, okay, which forms sigma bond. The second one is side-to-side overlapping, which form pi bond. And there are 5 different hybridization. Okay, linear, which is in S with the name is SP. For trigonal planar with 3 electron pairs, right, SP2. Okay, if total 4 electron pair, SP3, 5 electron pair, SP3D, and then 6 electron pair is SP3D2. Okay, so the question, right, we may ask, what is electron pair? Do you still remember what is electron pair? Okay, so I just roughly got you all right. Electron pair actually is number of bonding pair plus number of lone pair. So equal to number of electron pair. Do you remember? Okay. Okay, I hope you all can recap. So there are 2 common approach to chemical bonding. The first one is valence bond theory. Another one is molecular orbital theory. So valence bond theory, right, mentioned that a covalent bond formed by pair up 2 electrons. And then the electron, right, must with opposite spin. Okay, one is upwards. Okay, upwards. Another one is downwards. Okay, when they overlap, right, they share a common region. Okay, and then this region, right, has high electron charge density. Okay, so as I mentioned just now, there are 2 types of bond. One is sigma bond, another one is pi bond. So what is the difference between these 2 bonding? Okay, let's check together. Okay, sigma bond is resulting from end-to-end overlapping. Okay, hujung dengan hujung has high electron density along the axis. So for example, this is an axis, right? So between 2 axes, right, there has high electron density like this. Okay, it free rotates, so it can move freely. Okay, all the single bond, right, has sigma bond. Okay, a sigma bond. So next check. Yeah. Okay. Actually, there are 3 types of sigma bond between S and S orbital. So for example, hydrogen with 1 S orbital and then another hydrogen atom with 1 S orbital. Okay, they will share a pair of electron. Okay, so I contribute 1, you contribute 1. When they share among themselves, right, it will form a common region. So this one is the formation of sigma bond. Okay. Always remember 2 electrons equal to 1 bonding. Okay, next. This is overlap between S and P orbital. So S orbital from hydrogen atom and then P orbital from fluorine atom. So here. So both of them, right, share 1 electron. Okay, and then form a bonding. So this is the common region. So it will form the sigma bond. So this is overlapping between S and P orbital. Okay, and then the third one is overlapping between P and P orbital. So for example, fluorine atom with fluorine atom, okay, they share 1 electron for each others, right, and then form at the common region and then form the sigma bond. So this is the introduction about sigma bond. Okay, how about pi bond? Okay, pi bond is different. Pi bond is like this, sideways, okay, sideways overlapping. Okay, normally this one, right, happens between multiple bond molecule and then has 2 regions of electron density. Okay, just now for sigma bond only 1, but for multiple bond pi bond, right, there are 2, one above, another one below. Okay, and then pi bond, right, hold 2 electrons that move through both regions on the bond. So later we check, right, based on the diagram. And then pi bond restrict rotation. If compare, right, just now sigma bond free rotation, but for pi bond, okay, restrict rotation. Okay, restricted rotation. So as just now in my double bond, that's why the first one is sigma bond. So this is sigma bond, and then the second one is pi bond. So for double bond compound, right, there are 1 sigma plus 1 pi bond. So for example, oxygen, okay? First, right, they will form a sigma bond. And then the second pair of electron, right, they will form pi bonds. So same concept, one upwards, another one downwards, okay? Overlap, up and down, okay? Sideways overlap. So these two, right, okay, these two overlapping, right, okay, form 1 pi bond. So you just need to label for one time, okay, pi bond. And then here is sigma bond, here. So how about triple bond? This is another example for nitrogen. For nitrogen, there's 1 sigma and then plus 2 pi bond. Okay, so based on the orbital diagram, right, we notice, right, okay, one pair, right, will form the one pair of the electron, right, from each of the nitrogen atom will form sigma, and then this one will form pi bond, okay, and then this one will form pi bond. So always remember when you draw the pi bond, right, must parallel. So you see, this one, okay, this pi bond, okay, the pattern is the same, okay, standard like this, okay, so they overlap, okay, overlap, okay, you see, you have to make sure that the overlapping is correct, and then same for here, overlap. So this is one of the pi bond. Another one, okay, is a box form, okay, is box. This is label in box form. Actually, we no need to do the labeling also, never mind, because I want to show you, all right, the pairing of the pi bond must be parallel. That's why okay, this one in box form. So of course you have to label the arrow as well. This one upwards, okay, another one downwards. Same for here, this one upwards electron, this one downwards electron. And then you have to show the pairing up and down. Then only will form a pi bond. So for pi bond, you just need to label for once for one pi bond. This is labeled for another pi bond. Okay. Okay, so this is the introduction about overlapping and then the type of bonding. Okay. So this is another example. This is NO positive. Okay, please do remember, right, when these polyatomic ion with charge, right, when you draw the Lewis structure, must with charge as well.
Teacher Kon?
Yes.
Teacher Kon, there is a question
Yes,
from Shara
Yes,
Hisham.
Teacher Tang.
She asks whether we need to show the line.
Hello.
Hello? Can you hear me? Teacher Kon? Can you hear me?
Okay, yes.
There is a question from Shara Hisham. She asked, do we need to show the line?
Yes. Yes, I can. Can. Teacher Tang? Yes. Yes, yes, I can hear you.
The students ask, do we need to show the line?
Which line? Is it?
I think it's the orbital overlapping line.
The line is referred to.
I think she is asking
the overlapping, right? Is it this?
Yeah, I think so.
Is it this one?
Yeah, because she just wrote whether need to show the line. I think that is what she referring to.
Okay, if I show you by the yellow color, if you ask about this line, the overlapping between the pi bond, yes, we need to show the line. Okay, another one is showing the other pi bond. Okay, wait, the other pi bond. Okay, I show with blue color. Okay, this is the pi bond overlapping. Yes, we need to show. If you ask about the orbital, the internal one, okay, the blue one, if you ask about this straight line, right, we no need to show the line. Okay, and the box one, okay, kotak-kotak ni garis-garis kan. Sekadar untuk menunjuk bagi you tahu, okay, semasa kita pair up, right, mesti selari. Okay, so the internal box, okay, the internal straight line, we no need to show the line, is fine. Okay, yeah? But you must show the line which I highlighted with yellow and blue. Okay, the yellow color represent one pi bond, the another blue color represent another pi bond. Okay, I hope I answer your question, Shahrul. Okay, let's continue. Okay, that's just now I said, right, this one is NO with positive ion, right? If NO with positive ion, okay, and then when we draw the Lewis structure, we also have to show the positive ion. Of course, when we draw the hybridization diagram, right, we also have to show the positive charge over here. Okay, and then for this diagram, okay, because just want to introduce you all about the pi bond, that's why by right, we have to label for the N and oxygen atom. No worry, later when we proceed for the details drawing, right, I will guide you all more. Okay, so now we move on hybridization. So just now hybrid overlapping, now it's hybridization. So according to definition, right, hybridization is missing campuran, okay, two or more orbital. Okay, Okay, we have learned about S orbital, we have learned about P orbital, we have learned about D orbital. Okay, now we are going to mix this orbital and then form a new set of hybrid orbital. Okay, why do so? Okay, because right, the hybridization right can cause more stable bond and are consistent with the observed molecular shape. Okay, still remember in part 2, right, we learned about linear, trigonal planar, tetrahedral, and so on. So now when we draw the hybridization diagram, right, we have to follow the molecular geometry. Okay, so now let's check. Just now I said there are 5. So this is the first one. SP hybrid orbital. It's missing between one S orbital with one P orbital, and then form 2 SP hybrid orbital. Okay, and then involve 2 electron pair. So this is the normally linear, right? The compound with linear electron pair arrangement. Still remember what is electron pair arrangement? It can be electron domain or the basic geometry. Okay, so all go for the basic one. There are 5 basic geometry shape. So there are 2 bonding, so it will form a SP hybrid orbital with bond angle 180 degree. Okay, so I re-emphasize for electron pair is referred to number of bonding pair, okay, plus number of lone pair. Okay, for certain book, right, for number of bonding pair, but they will say number of sigma bond plus lone pair. Okay, both acceptable. Okay, the second one, this one is the second type of hybrid, which is sp2. Is missing between s orbital and 2p orbital, and then form 3 sp hybrid orbital. Why 3? Here, 1, 2, 3. 3 sp2 hybrid orbital. Okay, the electron pair involved, right, is trigonal planar. Can be 3 bonding pair or 2 bonding pair plus 1 lone pair. Okay, so total equal to 3 electron pair. As long as the electron pair equal to 3, right, so we're under sp2 hybrid orbital. The bond angle with 120 degree. Okay, so the third one is sp3. sp3 is the missing between the 1s orbital with 3p orbital, and then form 4 sp3 hybrid orbital. Okay, and then the electron pair involved is 4. Okay, can be 4 bonding pair plus 0 lone pair, or 3 bonding pair plus 1 lone pair, or 2 bonding pair plus 2 lone pair. So total equal to 4 will under this type of hybrid, which is sp3. So when you draw, right, must store in tetrahedral form. Okay, must label 4 sp3 hybrid orbital with the bond angle 109.5 degree. Okay, so this is the fifth one. The fifth one is sp3d hybrid orbital. Is the missing between s orbital and with 3p orbital and 1d orbital, and then form 5 sp3d hybrid orbital. So the electron pair involved is total is equal to 5. So I can be 5 plus 0, 5 plus 0, 4 plus 1, okay, 3 plus 2, or 2 plus 3. Here, hope you all still remember 5 plus 0, what is the molecular geometry? Actually, all the basic geometry is trigonal bipyramidal, but the molecular shape is different. So this one is still the same because no lone pair. This one, what is the name? I hope all of you, right, still remember seesaw, and then this one T-shape, and then this one is linear. Okay, I hope all of you still remember the name. Okay, so you have to start to remember based on the drawing, right? You can predict the molecular shape as well. Okay, so now you have to label for 5 sp3d hybrid orbital. Okay, and then the bond angle involved for sp3d hybrid orbital, right? You follow the trigonal bipyramidal, which is 90 degree and 120 degree. Okay, so next, okay, so this is the fifth type of hybrid, which is sp3d2. Is the missing between s orbital with 3p orbital and 2d orbital, and then form 6 sp3d hybrid orbital. Okay, so always remember the total electron pair is equal to 6, and then the basic geometry or the electron pair arrangement is octahedral. When you draw, right, okay, draw like flower, there are 6 petals. Okay, there are 6 petals. Okay, and then all the petals, right, must label with sp3d2. And then the bond angle is 90 degree. So these 5 type of hybrid, right, is the introduction for you all. Okay, now we will go for the example. Okay, we will go for a few examples. Learn how to draw the hybridization diagram. Okay. Of course, before you start to learn, right, you must know the step. Okay, how to determine the hybrid orbital. Okay, I think most of you know problem in terms of identify the hybrid orbital. It's quite simple. You have to check for the number of electron pair. Okay, how to check the number of electron pair? Everything have to start from Lie structure. Have to draw the most plausible Lie structure. Okay, this is part one that we learned. Okay, after that, right, we have to predict the molecular geometry shape based on the valence shell electron pair repulsion theory. Okay, so you have to deduce, okay, there are how many bonding pair, there are how many lone pair. Okay, then you have to deduce the hybridization of the central atom. Okay, this one I got you all already, right? 2 bonding. Okay, if total 2 electron pair is linear. Okay, and then sp. If 3, so this one is trigonal planar. Okay, sp2. If the total electron pair is 4, so this is tetrahedral, hedral, okay, and then sp3. If the total electron pair is 5, okay, trigonal bipyramidal, so this one is sp3d. Okay, if total electron pair is 6, okay, then this one is octahedral. Okay, and then with the hybrid state is sp3d2. Okay, there are only 5 types of hybrid that we learned in this topic. Okay, don't try to create by yourself. Okay, always remember based on the number of electron pair and then determine the basic molecular geometry. Okay, for example, 5 if equal to 2 linear, then sp, and so on. Okay, don't try to create the others. Don't ask madam, is it sp3d3? So sorry, I don't know how to draw sp3d3. Okay, next. Last one, next step is orbital diagram. Okay, when we learn about this, right, we must know how to assign the electron. Okay, based how to assign. So we have to draw the orbital diagram and assign the electron for the central and terminal atom. So in this part, right, we are going to learn what is ground state, what is excited state, and what is hybridization state or hybrid state. And then explain. Okay, after you draw, you must know how to explain the diagram that you have to draw. And okay, so last one, draw. Okay, let's start. Okay, are you ready? We are going to do draw the first diagram. Okay, let's draw and explain it. Okay, I hope you all can take out a piece of paper and draw it together with madam. So let's go for the first structure, beryllium chloride. So this is our first structure, beryllium chloride. Okay, again and again, if you want to start a hybridization diagram, you have to start with Lie structure. It's a must. So this one is group 2. Okay, this one is group 17. So why I need to know the group of the compound? Because I need to determine the total number of valence electron. At the same time, right, I must know, beryllium is the central atom, okay, which is more electropositive compared to chlorine atom. So now, okay, 2 plus, okay, 2 chlorine atom, there are 7 valence electrons. So total, okay, 16 of electrons. Okay, so now I start to form bonding, okay, but between the central atom and the terminal atom. You see, I'm doing the revision with you all, how to draw a Lie structure. Okay, so minus 4 equal to, okay, 12. So now I have to make sure that the terminal atom octet. So now minus 12. Okay, minus 12 equal to 0. So there is no remaining electron. So in this case, right, okay, maybe some of you are confused. Hey, beryllium, the central atom haven't achieved octet yet. If you still remember, right, okay, I'm going to teach you, all right, for certain species is electron deficiency species, which is no need to achieve 8 electron for the central atom. So this is one of the species. So this one actually is incomplete octet. Okay, how do you know this already stable even though incomplete octet? Okay, sorry, my pen. Okay, my pen not well function. Okay, you should know, right? This is incomplete octet. Incomplete octet. Okay. So if you're not sure, right, never mind, you can check for the formal charge. If you check one by one, right, you know the formal charge for chlorine, beryllium, and then this chlorine atom all is equal to 0, meaning that this is the stable structure. So now we move on. What is the molecular geometry? So the class of compound is AB2 because 2 bonding. So the electron pair is linear. And then the molecular shape geometry is the same because there's no lone pair. Okay, don't forget when you mention about the molecular geometry beside the name, right, you have to redraw again. Okay, what is the difference between these two? Okay, for restructure, the shape is not really important, but for molecular shape, right, molecular geometry, you must follow exactly in linear form. And then you can ignore the lone pair for the terminal atom, just for terminal atom. Okay, so this is 180 degrees. Okay, so now we move on. Okay, for the orbital diagram. Okay, beryllium group 2, right? So I know this is 2s. This one 2p. Based on the diagram just now, right? Okay, wait, I should use another color. We need to form 2 bonding. One bonding, okay, beryllium, we need to form 2 bonding with chlorine atom, meaning that beryllium needs 2 unpaired electrons so that can form bonding with, can share the electron.
Maybe we shall stop for a while for the advertisement.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
So, before Teacher Kong continue the class, I would like to give the first
Saya tadi
four
sampai mana keluar tak?
class code.
Okay,
Teacher Kong, the hybridization on beryllium chloride. The slide hybridizations for beryllium chloride. Okay, so students, so for the first 4 class code is A100. A100. Okay, so again, A100. So the first 4 class code
Okay, sorry,
is
okay, so the line is not
A100.
stable.
Okay, so Teacher Kong, you may continue the class. Teacher Kong, can you share the slide? Teacher Kong, can you share the slide?
Okay, thank you, Teacher Tang. Okay, sorry for the interruption because the line is quite weak, okay, for my side.
Teacher Kong?
Sorry,
Okay.
Okay, so let's pray for it. Hope everything is fine.
Okay.
So,
So Teacher Kong, you need to share the slide first.
okay. Okay, wait. So just now I explained until which part?
The beryllium chloride, the molecular shape.
Okay, thank you, Teacher Tang.
Is that right?
Okay, so okay, here, right? Okay, so sorry for the server problem. Okay, let's move on. Okay, so the class of compound, right, is okay. Let me check. Okay, so this one, right, just now we have just now. Okay, I just moved it, right. The Lewis structure should be like this. Okay, so with 6 valence electron. So this is linear, which is have the unusual features, which is incomplete object. Okay, AB2, and then here is linear. Here's linear, and then with the shape like this, beryllium chloride. Okay, and then the bond angle, hey. Seem like a lot of interaction. Okay, so sorry for everyone. Okay, this one is 180 degree. Okay, so now we move on for the orbital diagram. So for orbital diagram, beryllium is group 2, which is 2s, 2p. Okay, we know, right, we need to form 2 bonding pair with the chlorine atom. Beryllium, is it chlorine? Yes, chlorine. So we try to write down the ground state for chlorine atom, which is 3s, and then 3p. So 3p because group 17 with 7 valence electron. Okay, so in this case, there is no unpaired electron for beryllium. That's why, right, the electron from the 2s orbital need to be excited. One is excited, okay, it will become 2s and 2p. Yeah, now there are 2 unpaired electrons can form the bonding with 2 chlorine atoms. Okay, so next hybrid state. So the missing between these 2s and 2p orbital form a sp hybrid state orbital. And then please do remember, here 2p, right, you have to label as empty orbital. Okay, empty orbital for the 2p orbital. So this part is for the orbital diagram. Okay, so for orbital diagram, we must show the ground state. Okay, the first one is a ground state. Second one is excited state. And then the third one is hybrid state for the central atom. For terminal atom, ground state is enough. But for certain case, right, there is no excited state. Later we check about it. Okay, now we need to draw, okay, between 2p and 3p. Okay, so how to draw it? So first of all, I have to draw the central atom. Okay, my drawing is not really okay, but I hope you all can understand it. Okay, 2p. Okay, so p orbital, this is the 2p orbital for beryllium. Okay, beryllium. And then overlap with the 3p orbital of chlorine atom. Okay. Sorry, I have to check some troubleshoot for something. Okay. Okay, yes. I redraw again for this diagram. Why? I cannot erase it. Okay, never mind. I just draw again one more time. I try to do it one more time because the erase icon is not allowed me to erase it. Okay, so this one, okay, here is the 2p orbital. Okay, for the beryllium. Okay. This is another 2p orbital for chlorine. Okay, so sorry. There are some technical problem from my drawing pad. Okay. Now I can erase. I have to label for the beryllium. I'm quite sad for today because why? My pen is not allowed me to draw the. Okay, I try to use mouse and draw because my pen is not function well. Okay, I try to use mouse and draw it. I'm using mouse. Okay, this is the 2p orbital. Okay, for beryllium. Okay, so sorry because I'm using mouse. Not the drawing is not okay. And then here I have to draw another orbital. This is for the chlorine p orbital. And then this is another chlorine p orbital. Okay, chlorine. So, Okay, of course, I have to show the pairing between the two electrons, between one is from chlorine and then from beryllium, and then from the sigma bond. Here also the same, the pair of the electron, okay, and then from the sigma bond. Okay, so here, right, just now is sp orbital, so I have to draw the sp, have to label the sp orbital. And then for the chlorine, which is 3p orbital. Okay, and then here also 3p orbital. Okay, so if you check the notes over here, right, I did mention you have to check the shape. Okay, this is linear shape. And then we have to label for the orbital. So 3p orbital for the chlorine, and then the sp, there are two sp orbital for the beryllium atom. Okay, so we have done the labeling for orbital. How about the atom? Okay, beryllium, chlorine. And then I have to label for the electron, yes. And then I have to show the sigma bond, yes. So when we draw the hybridization diagram, we have to ensure all of the point. Make sure the shape is follow the proper one. So in this case, it's linear sp. And then we have to label for the orbital, sp orbital for beryllium, and the 3p orbital for chlorine atom. Okay, so and have to draw the electron and then show the sigma bond. So the last part, explanation. How to do the explanation? So the explanation, right, is the sp hybrid orbital of beryllium atom is overlapped with 3p orbital of chlorine atom to form sigma bond. So this is our first diagram. Okay, there are another 7, I think 7 to 8 diagrams I'm going to explain. Okay, now we go for HCN. HCN still hybrid orbital. Okay, as usual, we have to draw the Lewis structure first. Okay, I'm trying. Okay, this is group 1, group 4, and group 5. So 1 plus 4 plus 5. So total equal to 10 electrons. Okay, so H form bonding with C and then form bonding with nitrogen. So minus 4 then equal to 6. Make sure that the terminal atom octet. So 1, 2, 3, 4, 5, 6. Okay, yeah, 6. But hydrogen is duplet, so it's okay already. But how about the central atom? Since the central atom not achieve octet yet, right, it will form multiple bond. So I will try to form one bonding. Okay, if I find one bonding, only 6. So I will try for another bonding, then only octet for carbon. So this is the Lewis structure for HCN. So in this case, right, okay, always remember, multiple bond consider as one bonding pair electron, consider as one. So that's why class of compound for this case still the same, Fe2. So the electron pair arrangement linear, molecular geometry linear, and then we have to draw, okay, for this case, the Lewis structure and the molecular geometry diagram is the same, okay, like this. Okay, just now the Lewis structure, I forget the lone pair. Okay, so for molecular geometry, okay, you can draw it like this, settle. And then the bond angle still the same, 180 degrees. Now we move on for the orbital diagram. Okay, always go for the ground state one. Okay, go for the ground state first. Nitrogen, I know is 2s, and then 5 electrons, so 2p. Hydrogen is, okay, 1s. Okay, and then carbon. Carbon, okay, this one is for carbon, central atom is carbon. So with 2s and then 2p. We have to study based on the diagram, you must know. I'm actually HCN, there are 2 sigma bond. Okay, and for the C triple bond N plus 2 pi bond. So in this case, I still need 4 unpaired electron. Okay, I still need 4 unpaired electron to form 2 sigma and 2 pi bond. So in this case, there are only 2 unpaired electron. It's not enough. So that's why one of the electron from the 2s orbital need to be excited. So then it will become like this. Okay, like this, excited. Yeah, please do remember, right, label 2s and 2p. Now, as I know, there are 2 sigma, right? So it will form sp hybrid orbital. Another 2 electron we label as 2p, and then bracket. Okay, some will write down pure orbital, some will write down unhybridized orbital. Up to you all, both acceptable. So I prefer write down pure orbital. What is the function of this pure orbital? For pi bond. Okay, now we need to draw the hybridization diagram. Okay, I hope my pen is okay for me to draw. Okay, first. Yeah, everything fine? Yeah, okay, thank God. Yeah, I can draw by using pen. Okay, and then N. Okay, N. N is p orbital as well. Okay, and then here, H is S orbital. Okay, so this is hydrogen, this one is carbon, and then this one is nitrogen. Okay, you should know. Okay, I have done for the sigma bond already. Why? Because carbon share and pair, they share and pair of electron, and then form a sigma bond. They share pair of electron, and then form sigma bond. Okay, so I have done for sigma bond. How about pi bond? There are two pi bond, right? As I mentioned just now, for the pi bond must be parallel. So I have to use another color for you all to show the pi bond. Okay, I try to use blue color. Okay, one I will slant it to this side. So this is the first pi bond. Okay, sideway overlap. Okay, you try to draw the size of the orbital, right? Okay, is more or less the same. Okay, this one you have to practice. Okay, more they only can draw a nice hybridization diagram. Okay, another one I use the green color. Okay, you can try to adjust by yourself as long as I draw a P loops. Okay. Okay, I have done. Okay, a bit not nice for the red color, right? Never mind. I hope you all can read. Now I want to do the labeling. Okay, I have to do the labeling. I use black color. Okay, so this one upwards, another one downwards, and then overlap. Upside overlap, downside overlap, and then label for the 2p orbital, 2p orbital. Same for the blue color one, up, down. Okay, must be parallel, upside overlap, okay, downside overlap, label for the 2p, 2p. And then double check what else. Okay, here nitrogen, carbon, hydrogen. Here you must write out one as orbital. Here sp, sp. And then for nitrogen, 2p orbital. So now we double check for everything. Is it everything have done? Oh no, I forget the pi bond. Yeah, one pi bond, two pi bond. Okay, so check. Is it in linear form? Yes, in linear form. You see the red color? The red color show it that this HCN is in linear form. Okay, next label for the orbital, 1s, sp, sp, 2p, 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 2p. Yes. Okay, and then atom. Okay, here hydrogen. Okay, chlorine, I try to label for one more time here, carbon. And then here nitrogen. Okay, done. Okay, sigma bond, yes, 1, 2, sigma bond, yes, pi bond, 1, 2. And then the pair of electron, yes, sigma pair, pi pair, yes. So this is a complete diagram for the complete hybridization diagram for HCN. Okay, now of course we must know how to explain the diagram. So the explanation, right? Okay, the first one is here. Is referred to here. The sp hybrid orbital of carbon, this is the carbon atom, is overlapped with the 1s orbital of hydrogen atom to form sigma bond. Okay, the second explanation is referred to here. The sp hybrid orbital of carbon atom is overlapped with the 2p orbital of nitrogen atom to form the sigma bond. And then the third one is referred to the green and blue color because the pattern is the same. So we just need to explain for one time. So the 2p hybrid orbital, is it hybrid? No. Okay, just 2p orbital of carbon atom is overlapped with 2p nitrogen atom to form the pi bond. Because here is pure orbital, that's why we just need to 2p orbital. If you want to write down 2p pure orbital is fine. Okay, but this one is not hybrid, just 2p orbital. Okay, get it? So by using HCN, this example, right, we have the chance to draw the sigma bond and pi bond. Here, now we move on another example, which is BH3. B, group 3, boron group 3, and then H is group 1. So 3 plus 3 times 1 equal to 6. So boron, and then form hydrogen, hydrogen, hydrogen. Yeah, this is the Lewis structure for boron hydride. So the class of compound AB3. No, AB, is it AB3? Yes, because 1, 2, 3, AB3. So electron pair arrangement is trigonal planar. Okay, trigonal planar. And then the molecular geometry, trigonal planar as well. Okay, now you have to draw the trigonal planar for B, H, H, H. As I mentioned just now, V structure is doesn't matter, but for molecular geometry, must draw in the trigonal planar form with 120 degree. So now we move on for central atom, Boron, okay, boron group 3, right? So group 3, yes. Okay, 3 valence electron. So as we know, we need to form 3 bonding with the hydrogen atom. Okay, need to form 3 bonding with the hydrogen atom. So I need to ensure that there are 3 unpaired electrons, meaning that one of the electron from here, right, this one need to be excited. So the excited state should be like this. Okay, so 2s, 2p. And then these 3 electron mixed together become a new set of sp2. Wait, sp2, just now what I mentioned just now. sp2, right? So ab2, correct. Atom count a bit blur today, So, yeah, correct. Okay. So, yes, sp2, 1s. Now we move on for the drawing. Okay, double check, always double check. So the drawing is simple because it's trigonal planar, right? So you have to draw like trigonal planar like this. Okay, make sure that the shape of the loop is more or less the same. And then s orbital, s orbital, s orbital. Okay, actually, right, this diagram a bit small. If a bit small, right, it's quite difficult for you to label. I would encourage you to draw a bigger diagram. So easier for you to label. Okay, so I try to draw a bigger one. Okay. Kena ingat kalau boleh buat besar-besar sikit. Besar sikit supaya senang buat label. Okay, so like this. Okay. Oops. Okay, and then draw a sphere here. Easy for you to label sigma here. Sigma. Okay, for you to label sigma. Okay, the sequence doesn't matter as long as you remember to label all. Here, sigma. And then here is for the hydrogen. Okay, 1s we label orbital inside, 1s, hydrogen outside, hydrogen outside, hydrogen outside. Okay, so here, label 1s. So what else? Don't forget about the boron. And then here sp2, sp2, sp2. Is it settled? Double check. Yeah, trigonal planar label for the orbital sp2 for 3 times. And then 1s, yes. Atom boron, hydrogen, yes. Okay, and then the sigma, there are 3 sigma bond, yes. Okay, there are 3 pair of electron, yes. Always write down this one for you to check whether the diagram is complete or not. Yeah, so the explanation is simple. The pattern is the same. The sp2 hybrid orbital of boron atom is overlapped with the 1s orbital of hydrogen atom to form the sigma bond. Okay, I hope all of you get the idea already. Yeah? So next, tetrahedral is the same. Okay, I want to show the special one. Okay, this is tetrahedral. Okay, this one is trigonal bipyramidal. Okay, label is wrong. Trigonal bipyramidal. Okay, I want to show this one. Okay, I want to show this one. Just now, right, all is without the charge. Okay, I want to show the something with the charge one. This one with positive charge. Okay, with positive charge. Okay, so how to do this question? If with positive charge, what is the difference with the previous one? Let's check. I, group 7, group 7. Okay, so 7 times, okay, there are 5, right? 35. Okay, minus 1 because positive, so equal to 34 electrons. Okay, Madam Kong shortcut. Actually, right, you have to do 7 plus 7 times 4. Okay, I shortcut straight away 7 times 5. Okay, equal to 35 minus 1, 34. Okay, and then I form 4 bonding with fluorine atom. Okay, then minus 8. So equal to 26. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So minus 24. And then equal to 2. Yes. So in this case, right, okay, there are combination between bonding pair and lone pair. So this is AB4E1. So it's the basic geometry, trigonal bipyramidal. Trigonal bipyramidal. And then this is seesaw. Seesaw. Okay, so when you draw the molecular geometry, right, must look like seesaw. So lone pair is here, and then foreign, 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 foreign. The bond angle is less than 90 degree and less than 120 degree. Okay, so this part, please be careful. Because we know that is positive, right? We must know the positive charge is belong to which atom. So based on here, right, you have to check the charge. Okay, IF4 positive. Okay, wait, something wrong for this structure. IF4 positive. Is it 1, 2? Okay, positive. Okay, seems like this question got something wrong, huh? IF4 positive. Yes.
Trigon, the formal charge positive one is on iodine.
Yeah, on iodine. Okay, 7
minus 6. 7 minus 6.
7 minus 6. Yeah. Wow, how? Okay, we just try to do some revision. Okay, 7 minus, okay, 1, 2. There are 2 lone pair plus half times 8. Okay, so 4. Okay, get it? Plus 7 minus 2 plus half times 8. So 2 plus 4 equal to 6. 6 minus 6, 7 minus 6 equal to positive 1. Yeah, like this. Okay, sometime, right, you forget. Okay, why? There are, by right, there are, okay, by right, okay, the positive 1, sorry, because iodine, by right, there are 7 valence electron, but the positive charge is belong to I. So meaning that when we draw this ground state, right, it's referred to I positive. So I positive, right? Okay, 1, 1, 2, 3, 4, 5, 6. Okay, like this. Okay, if we draw it like 7, right? Okay, something wrong already. If 7, you cannot explain the diagram. So meaning that you have to check for the charge as well. Here, so it's I positive. So this one is I positive. Here, student always confuse between this part. So you can check the formal charge for each of the atom and identify the positive charge is belong to which ion or atom. Okay, now we proceed. Okay, this one is 5s and then 5p. So this one we have to remain. Why? Because based on this diagram, there is one lone pair. Okay, so this pair of electrons have to be remain, and then this one need to be excited. Why? Because we need to form 1, 2, 3, 4. 4 bonding pair. So now we continue with excited state. This lone pair have to be remain here. So excited, 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 excited. So here is 5s, 5p. Okay, do remember label 5d for here as well. Label 5d for here as well. Okay, now is missing between the 5s orbital and 5p orbital and 5d orbital. So once it's mixed together, right? 1, 2, 3, 4. So it will become sp3d hybrid orbital. Please do remember 5d and p orbital have to label empty orbital. Okay, and then do remember the s as well. Okay, foreign, 2s, 2p. Okay, so this is the orbital diagram for the ground state foreign atom. Okay, so everybody must know how to draw the orbital diagram for IF4 plus. Okay, Madam Kong repeat again. So here, right, because since there is one lone pair, so when we draw the orbital diagram, we have to ensure, right, we remain one lone pair. Okay, because we determine the hybridization of the central atom based on the number of lone pair plus number of bonding pair. So here, 1 for the lone pair, and then these 4 are for the bonding pair. So these 4 ampere electron is for the bonding pair formation between the iodine ion with the foreign atom. Okay, now we proceed with the drawing. So this drawing is trigonal bipyramidal. So trigonal bipyramidal, so we have to draw 5 petals. 1. Okay, and then another one like this. Okay, 1 like this. Okay, one like this, and then one like this. Okay, actually, right, these 5 pattern, right, you have to draw the shape more or less the same. Okay, meaning that one of this one I have to redraw again. This one a bit out. Okay, so you try to practice by using your pencil. Pencil is much more easier. Okay, compare draw by using the drawing pad. Okay, so I miss face-to-face teaching. Okay, and then another P orbital here. This is for the 2P. Okay, here for the 2P. Okay, here for the 2P. Here for the 2P. Okay. Wait. If we draw on whiteboard, right, we can rub a bit only. But if you draw on drawing pad, if you rub, right, all erase. Okay. Yeah. Okay. So now I proceed with the labeling. Okay, shape. Okay, this one is the trigonal bipyramidal shape. Okay, if you draw like this also can. Actually, it's the same. Got student ask me whether can I draw like this. Actually, it's the same. Okay, now you want to upwards or downward. Actually, it's the same. As long as it's trigonal trigonal bipyramidal form. Okay, both acceptable. Okay, now I try to label. Okay, using blue color. So I label the orbital first. 2P, 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 2P. And then SP3D. There are 5 SP3D. Make sure you label for all. SP3D, 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 SP3D. Okay, so this one is lone pair. You have to show the lone pair. And then this one, okay, sharing between the fluorine atom and iodine ion and then form sigma bond. Sharing between the fluorine atom and the iodine ion form the sigma bond. Yeah, fluorine atom, okay, form sigma and then form sigma. Okay, so 1, 2, 3, 4, 4 sigma and 1 lone pair. Yes. Okay, next, atom. Fluorine atom, fluorine atom, fluorine atom, fluorine atom. Here I will just label iron. Okay, because there are some difference between matriculation level and STPM. STPM they will label like this, I positive. Okay, like this, I positive. Okay, I think matriculation will accept as well, but most of the time when we teach, right, okay, we will just ask the student label as I. Okay, we label as, because that day we discussed with teacher Vila, right, STPM have to label on the atom, okay, I. But for matriculation, we can just atom and then bracket like this. So with positive. Okay, matriculation accept this one. But for STPM, right, we have to label I positive. Okay, please don't label 2, just label once because just one positive charge. So now the explanation is, yeah, sp3 hybrid orbital of this one is iodine ion. Iodine ion is overlapped with 2p orbital of fluorine atom to form sigma bond. Okay, actually, right, there are 8 examples that I want to show, but due to time, it's not enough. So I just able to show the linear. Okay, one is linear sigma bond, another linear with pi bond and sigma bond, and trigonal planar with 3 sigma bond, and this one. Why I show this one? Because right, more of the student, they will confuse. Okay, they will confuse between the for the orbital diagram, because there is one lone pair. So when we assign the electron for the central atom, right, we must make sure that we have to remain one lone pair. Okay, khas untuk lone pair. Okay, kita kena pastikan ada satu pair of electron khas untuk lone pair. Another special of this case, right, is positive charge. We have to find out the positive is belong to which atom. Since it belongs to the central atom, right, so we must minus 1. So initially, iodine atom is with 7 valence electron. Now we know, right, iodine charge, positive 1, we need to minus 1. That's why it will become 6. So total here, 5s, and then 5s2, 5p, 4. Okay, then only 4. If not, right, you are unable to proceed. Okay, a proper one. Okay, I want to show you all one example for the this one, I. So we know, right, in this case, okay, I just straight away to show you all the Lewis structure. For I, right, Okay, should be like this. There are two lone pair. Okay, later you try, right? You know there are two lone pair. In this case, okay, I need to form 4 bonding pair and then 2 lone pair. So that's why this one is under category octahedral. Okay, so if I draw the orbital diagram for I, right? Okay, we will notice, right? Okay, it's not enough. Okay, I with 7 valence electron. Okay, with 7 valence electron, I is 5s, 5p. Okay, if we remain 2 for lone pair, okay, I need 4 unpaired electron, lack of 1. So, meaning that there are something wrong. So, we have to check. So, in this case, actually, I is with I negative, meaning that there are 8 valence electron for this iodine ion. Okay, now it can be excited, and then form 4 bonding pair with the chlorine atom. So, the excited state, right, for iodine is like, okay, remain 2 lone pair, remain 2 lone pair because here 1 lone pair, 2 lone pair, and then form 4 bonding pair. So this is for the excited state. For the orbital diagram for I negative. Okay, this one is I negative, I negative. 5s, 5p, and then 5d. 5d. Now mix together. Okay, so this is sp3d2 hybrid orbital. Okay, so I think that's all for today. So try to, okay, you can try the exercise. There are 8 examples. You can try to do it by yourself. Okay, you can try one more time. The first one is beryllium chloride, Sp, HCN, Sp, and then BH3, Sp2, CH4, Sp3, and then PCl5, Sp3d, something wrong here, Sp3d because copy and paste, Madam Kong forget to change it. Okay, and then this one we explained just now, which is IF4, Sp3d, and then this one SF6, Sp3d2, and then ICI4 negative, Sp3d2. Total, there are 8 examples. You can try to do it by yourself. Okay, I think that's all for today. Okay, sorry for all the inconvenient calls. Okay, hope you all continue to stay tuned with us every Sunday, 3:30 until 4:30 p.m. Okay, thank you, class.
With God's grace, we are done with today's sessions. We have learned a lot from Teacher Kong on orbital overlapping and hybridizations. Congratulations to those who are able to follow our sessions from the beginning till the end. And thank you very much to Teacher Kong for such an interesting lesson. Before I provide the certificate link, let me give you the last 2 class codes, which are 1, 8. So the last 2 class codes are 1 and 8. Okay, 1 and 8. Now, please off the live chat button and click subscribe button if you haven't. This is to show your appreciations to Teacher Kong for giving you a free lesson today. Don't forget to click the bell button so that you won't miss any new videos and live classes from Teacher Kong. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today. Sharing is caring, right? When you have finished, type down in the chat sessions and the certificate link will be provided. Once again, I would like to thank Teacher Kong for interesting lesson. Thank you also to Teacher Vivi Lau and Cikgu Mawar for being with us today. I think that's all for now. See you in another sessions. Goodbye everyone and have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau.
Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.